All right, you are going to be opening up to the distributive property page in your green notes booklet. So we're going to look at the last of the 4 properties in math today. And we did a little bit of the notes today, but now I'm going to kind of explain to you what they mean. So the distributive property, like we said, distribute, the root word of that, just means to split equally among groups of things or to give out things. And that's what we're doing with these numbers today. We're giving them out equally to another set of numbers. So the single term on the outside, which is this guy right here, and this guy right here, of a set of parentheses must be multiplied by all the terms inside the parentheses. So when I was taught this, I was taught to draw arrows in. I draw an arrow from the outside number to the first inside number and draw an arrow from the outside number to the second inside number. And as I draw that arrow, I am distributing this outside variable or outside number equally among each of these in here. And when we distribute that, that means we're multiplying the outside number by each of the inside numbers. So we end up getting a problem that looks like this. 8 times 4 and 8 times 3. Then whatever operation I'm doing with the numbers inside the parentheses transfers down below. Okay, so now my problem is 8 times 4 plus 8 times 3. So I know that 8 times 4 is 32 plus 8 times 3 is 24. When I add those two together, I get 56. Okay, now going back to what we have up here. If I was not to use the distributive property knowingly to solve this, I could figure out what my inside parentheses are equal to. And I know that 4 plus 3 is 7. So then I would multiply 7 times 8 and I would get 56. However, what you're doing is when you're doing the 4 plus 3 in the inside, getting 7 and multiplying that together by the outside number, you are actually doing the distributive property. You're just doing it 2 steps advanced, okay? Now, when we move down to the bottom problem here is where this is going to make a little more sense. We're not given both of these numbers on the inside. We're missing a number here, so we have a variable here. So I'm going to do the same process. I'm going to take that outside number and distribute it to each number inside the set of parentheses. And when I distribute that, that means I'm multiplying it by each of the numbers on the inside. And I'm distributing it or splitting it equally among the 2 numbers on the inside. So when I multiply these 2 first numbers together, I don't know what this number is. I'm given a variable here. So that means I can't necessarily multiply to find an exact answer like I did up here. So I'm going to leave it as 2x. And then what we've worked with before in order of operations, we know that a number right next to a variable, just like we have here, is showing us that we multiply them together. Okay, so now we have 2x. My sign transfers down, and then I multiply my outside number by my second inside number, which is 2 times 2, and I get 4. And now I've created an expression that if I knew what x was, I can plug that value in and I could solve using order of operations here. This would be my answer or my expression using the distributive property to simplify this guy up here. Let's do a few more examples over on the next page here that's right next to the distributive property. So I'm going to do some examples. And the first one we're going to do is we're given 7 times the group of x plus 4. Okay, so using the distributive property, I'm going to draw in my arrows. If it helps you to do that before you solve or as you solve, go right ahead and do that. And when I draw my arrows, that means I'm transferring this outside number to each number inside the parentheses, which means multiply. So I end up getting 7x, or 7 times x. My sign stays the same and it transfers down. And then I end up getting 7 times 4, which is 7x plus 28. That would be my simplified expression using the distributive property. Now, if I knew what x was, I could plug that in, solve it, whatever's going on in the inside here, and then multiply it by the outside, and I could get that value, okay? Now, this would be my expression that I'm given, that I could use to solve that problem. let's do another one here. Let's do 5 times, oops, that's a 5. 5 times the group of b minus 2. 5 times the group of b minus 2. Okay, when I am using the distributive property, I'll draw in my arrows and I'll distribute my outside term to each term on the inside. So I end up multiplying them together and I get 5 times b, because I don't know what b is, so I'm going to leave it as this. My sign transfers down, and then 5 times 2, I end up getting 10 as my answer, and that is my expression using the distributive property. Okay, we'll do maybe 2 more like this, and then we will work backwards with them. Okay, so now let's do 4 times the group of 10 plus n. 4 times the group of 10 plus n. You'll notice that these two problems up here, I started with my variable inside the parentheses, and then my value was the second number. But now it's flip-flopped, and we're still going to use the same process to solve. So I'm going to use this term on the outside, and I'm going to distribute it evenly to both on the inside, and when I distribute, that means I'm multiplying them together. So now when I multiply 4 times 10, simplifying that expression, I get 40. My sign transfers down, plus, and then 4 times n. I don't know what n is, so I can't simplify that anymore than 4n. So my expression using the distributive property for that would be 40 plus 4n. All right, one more. I'm going to do the following problem. I'm going to do, let's use p plus 6 on the inside, and let's do 3 on the outside. And you'll notice that my outside term is actually on the opposite side of the parentheses than what it was in these 3 problems here. You would do exactly the same thing. You're still distributing that guy on the outside to each guy on the inside. You're just going in the opposite direction with it is all, but it will still end up being the same process. So when we distribute 3 to 6, I multiply them together and I get 18 plus, my sign transfers down, 3p. And that would be my simplified expression. Okay, now we are going to be working with them in the backwards form. So I'm going to put a line underneath here. And what we're going to do is we're going to be given these expressions, so this part of the problem, and we're going to try to figure out what this part of the problem would be. So my first example for working backwards with it right now is going to be this. Let's do 8x plus 32. Okay, so now we're given part of the answer that looks like this. We're given the expression. And now I'm going to introduce a new term to you, which is factor. So when we are factoring something, I'm going to write the definition over here, we are pulling out, which is actually dividing, the GCF. So when I'm factoring out, or if I say to factor these two, that means I'm going to find the GCF of 8 and 32, and I'm going to divide each one of those by that. So I know that the GCF of 8 and 32 is 8. 8 can go into 8, 8 can go into 32. So I'm actually going to divide each one of that. And when I divide each one, that means I'm pulling my GCF, so whatever I can divide each one of these by, is now going to become my outside term. So that means it's going to be pulled on the outside of the parentheses. And what's left inside is what I get when I divide 8x and 32 by 8. So if I divide 8x by 8, I'm left with x. My sign stays the same. And when I divide 32 by 8, I get 4. Now my answer will be 8 times the group of x plus 4. And one way to double check is to use the distributive property and draw on your arrows and see if what you get when you use the distributive property matches this original problem. So I know that when I were to, or if I were to distribute this out, I would get 8 times x, which is 8x, plus 8 times 4 is 32. And let's do another problem here. If I had the group of 5m plus 30, I'm going to find the GCF of 5 and 30. So the GCF of 5 and 30 is 5, and that's the number that I'm going to pull on the outside of the parentheses here. So when I pull it on the outside, that means I'm dividing each of these terms by that GCF. So when I divide 5m by 5, I'm left with m, and then my sign stays the same, and I divide 30 by 5, and I get 6. So 5m plus 6 is my expression, and I can double check, use the distributive property, draw in my arrows. 5 times m is 5m, plus 5 times 6 is 30. Okay, now let's do another problem here. Same concept, same process, but we're just going to flip-flop these two terms around. So if I'm given 24 plus 3x, and I was asked to simplify that expression or factor that expression, what I'm going to do is divide each one of these by my GCF. So when I do that, I pull this outside number, outside the parentheses. My GCF of 24 and 3 is 3. Divide that and I get 8. So 24 divided by 3 is 8. Carry my sign down. 3x divided by 3 is x. And that would be my answer. So I would draw on my arrows if I need to double check. 3 times 8 is 24, plus 3 times x is 3x, and I get my answer. Right, we will do one more problem just to have a set of examples in our booklet here. Let's do another one like this set up here. So 50 plus 10p. And let's find the greatest common factor of 50 and 10. And I know 5 can go into both of these, but I know 10 can go into these more. It's the greater common factor. So 10 is going to be my outside term, what I'm dividing each one of these terms by. So when I divide 50 by 10, I'm left with 5 on the inside. My sign carries down. And then 10p divided by 10, I'm left with p on the inside. And again, go ahead and draw on your arrows if you need to double check and see if it matches up there. All right, your homework for today is going to be this page that was handed out last week. And actually what I'll do is I'll zoom out really quick so you can copy down these notes if you need to. Pause the video. Otherwise, this is the sheet that you are going to be completing for your homework today. It even has the date on here today. So you have 12 problems up at the top. The first 6 are going to match the top examples that are up here. Okay, so you're going to be drawing in your arrows if that's your process. You're going to be simplifying that expression, giving me your multiplied out expression. The bottom 6, so 7 through 12, are factoring. So you need to factor out the greatest common factor, and it's just like these bottom examples down here. You do have a word problem at the bottom. It says a baking company charges $1.75 per slice of cake for baking and 35 cents per slice for decorating. How much would a decorated cake cost containing 150 slices? Write an expression and find the total cost. So going back to these problems up here, you're given $1.75, which is this cake. And then if you want to decorate it, it's another 35 cents. So together, these are one slice. You're going to be creating an expression for not only one slice, but if you're buying 150 slices, think about how you would use the distributive property and think about maybe how you would write an expression like these up here. And then you're going to find the total cost down here.